All right, welcome back to Thursdays with me. I'm Ron. We're going to do some goal setting stuff in data sufficiency today. So, yep, you'll see what that means when we do it. Let's go ahead and show that copyright notice again, and then we'll jump into it. Okay, the problems that we're doing today are all from, unless we tell you otherwise, they're all from the free GMAT prep software and our copyright, GMAC. Also, don't forget, they're going to have choices A through E. Please indicate the A through E answer in the right place, which is here. Please do not put an answer in the chat. Okay, let's do one. Let's do a problem. How about this problem? Okay, again, this is a data sufficiency problem. We do kind of assume that you understand what answers A through E mean here. If anybody doesn't remember what the choices mean, you can let me know in the chat. I can post the answer choices, although we won't go into like what does sufficient and not sufficient mean, but if anybody needs the A through E answers posted, just let me know and I can post them. But give this problem a shot and please indicate your answer in the chat box. Okay, give you a little bit of time to do that. We should probably be wrapping this one up pretty soon. If you are still actually making progress, you should still be going. If you are not genuinely, actually still making progress, then you should not still be going. Remember, that's all that, at the end of the day, too, remember that's all that time management actually means on this test is, can you cut it when you are not actually making progress anymore? So do keep that in mind. So a lot of people have gotten answers. So we have like Amanda, Balaji, Helen, Katie, Swayze, Kyle, Mohana, Rhoda. Should pick a multiple choice answer, please. Okay, let's start talking about the problem. And remember what today's theme is, by the way. Today's theme is that goal setting, data sufficiency. I mean, let's make sure we talk about what we mean by that, because this is a thing. In fact, it's one of the primary things that motivates data sufficiency. Like, it's one of the reasons why data sufficiency exists in the first place. So, I mean, here is a very simple version of a data sufficiency problem. Let's just make this really simple. Like, what is 2x plus 2y? And let's say statement 1 is x plus y is 5. It's supposed to say 1. I'll fix it in a second. And there's statement 2. That's statement 1. I mean, okay. So just look at that for like 10 seconds and tell me in the chat box what's the answer to that. Actually in the chat, not in the multiple choice part. The answer to this is A. It's a multiple choice problem, so it's not a number answer. I mean, somebody put 10. it's still a data sufficiency problem. So yeah, like this is A, right? Because if you have statement 1, all you have to do is double it. And then if you have statement 2, then you... Okay, I think my audio cut out for a second. You can see right away that statement 1 is sufficient because if you have x plus y is 5, then all you do is double it, right? If you have this, then 2x plus 2y is 10. So that's sufficient. But if you have statement 2, I mean, this might take a second for you to think about. I mean, statement 1 should be immediate. And then in statement 2, you might have to think through why it's not sufficient. But, you know, you can just test cases if necessary. I mean, like, if x minus y has to be 2, right? So if x could be 2 and y could be 0, that's one case that works. Then, you know, 2x plus 2y is 4. But you could also have something like 102 and 100. That you know, 2x plus 2y is some bigger number in that case, but there's no reason to calculate what it is because it's definitely something other than 4. So this is not sufficient. So give me a smiley face if this makes sense. Okay. So now what I want to talk about is, like, I mean, this is supposed to be a pretty simple example. They're not going to give you anything that's this uncomplicated. But you don't want to get too philosophical with this stuff. Like, basically, if you can get 2 different answers, then you can get 2 different answers. And that's how it works. So as long as you know that not sufficient means you can get 2 different answers for that. And sufficient means there's only one answer for that. So let's talk about this whole idea of goal setting here. I mean, if you realize a couple of things, if you realize that the goal of the problem is to find 2x plus 2y, just that quantity, like all you care about is what is the actual value of 2x plus 2y. And so you don't care about finding x or y individually. Then you'll get the problem right. But if you actually think that you have to find x and find y, then you will get this problem wrong. That's the main point here. If you actually try to find x and y individually, then you'll pick C, and you'll get the problem wrong. Because, I mean, if you think you need the individual values, then you'd actually have to have both statements to get them, is the point. So, in other words, this is the whole point of this. If they ask you for that quantity, then that quantity is pretty much the only thing that you're going to find. And if you try to find anything more specific than what they're actually asking for, then you'll blow the problem. That's pretty much the idea here. I mean, give me smiley face if that whole thing makes sense to you guys. I mean, what you're looking at here is basically the entire reason why data sufficiency is even a thing that they made. Like, this is actually the motivation behind this problem type, is this. Because you can't do this to people in a multiple choice question. Like if I gave you a regular multiple choice problem and I gave you both of these statements, then you could actually find x and y, and then you could just plug them into 2x plus 2y. I mean, you could do that. And it would be a waste of your time, but you would still get the problem right. But in this data sufficiency setup, you're actually discriminating between people who have the correct goal and people who are just trying to find all the information they can find. So, like, this is actually the reason why data sufficiency exists. So, the takeaway that you should get from this is that whatever the goal of the problem is, you need to be really specifically focused on this. So this is the problem we were just doing. How many degrees greater is one angle than some other angle? It's kind of like me asking you for 2x plus 2y. Like if you think you got to find x and y, then you just lost that game. You just lost it right there. So, and like one more thing about this example problem, if you think that you have to find x and y individually, like if that's your goal, if you think that you're trying to do this, then you have already gotten the problem incorrect before even starting it. This is your goal. You've already gotten the problem wrong before even starting it. Because if you're thinking that, I mean, the thing is, nothing is going to correct you if you do that. Like if you think, okay, I have to find x and y individually, then nothing is going to get in the way of that. I mean, in other words, you don't even have to make mistakes to get these problems wrong. You just have to have the wrong goal in mind, and you can get it wrong. So, like in this problem, if you think that you have to find these two angles, then you have already got the problem wrong. You already got it before you even started. Because you should expect to find the difference that they're asking for. Like you should expect to find how much bigger is one angle than the other one without finding the angles, is the point. So, in other words, here's one angle. One of them is PQR, and one of them is, say it's orange and green. We want orange minus green. So there we go. That's the goal. The goal is to figure out the difference between the orange angle and the green angle. Any questions about that? That's better. Better than what? Okay, so there are two ways that we can do this. Yeah, those names are, I actually agree with that. I don't, these letters and stuff like that get confusing really fast. I mean, you need to be drawing this on your paper anyway. So when you draw this on your paper, you need to, you should just put labels on these things. I mean, you're not going to have colors when you take the test, but you can put like a X here and a Y here, and you can just be like, okay, my goal is to find X minus Y. That works too. So, but yeah, no, I mean, definitely don't leave them as PRS and PQR unless you can actually process that really quickly and easily. If you can, then leave it that way. But if you have any sort of, if you dislike that as much as I do, then yeah, it's very good idea to just write it in some other way. So yeah. Okay, orange thing minus green thing. So there's two ways we can do this. And one way is to do it algebraically. So let's talk about that. Let's do algebra.
And then what's the other way to do it besides algebra? Anybody in the chat? You guys know? Yeah, you test cases. Good. We'll do it both ways. So if this is, and let's blow this up nice and big. Remember, when you draw diagrams on your paper, guys, make sure you draw them nice and big. I mean, you need to make, I mean, a lot of people, if you're a small handwriting person, you might also tend to make diagrams that are like, I mean, everything is small, whatever, but like what I've noticed is that people who like to write really small handwriting tend to make little tiny cute diagrams that almost fit in like one line of writing. If you, I mean, the fine motor skill there is impressive, but if you make a diagram that is that small, you're not going to be able to write anything on it. And also remember that you don't really get a pen on the test. You don't have a choice of writing instrument. They give you that marker, which is, it's pretty thin for a marker, but it's like a stick pen. So you have to make diagrams that are bigger than you might want to. So let's say that, okay, they tell you it's 30 degrees is QPR. Okay. So let's say that that's X degrees. Then what's this big angle? QRP. Notice that this is a triangle. Yeah, you just take about a 180 because 180 degrees in triangle. So this angle here, and I mean you're finding this angle for a reason too. Remember, everything. The point of this whole lesson is that everything should be goal-oriented. But if you want to get at that orange angle, then you have to find this one first because it's abutting the orange angle. So this is 180 minus 30 minus x. So that's 150 minus x. And then, just a second. Sorry. Okay. I think I can make a degree symbol out of that stupid line under it. I'll try it a second. Okay, so this is, how do you find the orange angle now? It's not 30, 60, 90. In fact, nothing in this diagram is necessarily 30, 60, 90. Yeah, you have, this is these two angles together that I'm about to mark. Make a straight line. These two. So if you have, I mean, if you don't like doing this with algebraic expressions, then you should stop doing them and just use test cases. Like if it becomes too uncomfortable or too awkward or you lose track of what you're trying to do. But yeah, this is just 180 minus that blue angle. So that's 180 minus 150 minus x. And so that's 30 plus x. Aha, look at that, right? So you have x, and you have 30 plus x. So the difference, how many degrees greater? So orange minus green is 30. It's 30 plus x is always 30 degrees greater than x. So orange minus green is 30 plus x minus x, which is 30 degrees. So that's sufficient. I noticed the goal setting here. I mean, you don't find anything in this problem. Like we don't know what x is. So like nothing is a 30, 60, 90 triangle, for example. I mean, there's no x could be any number of degrees from 0 all the way up to 60 in this. And this could be any angle from between 30 and 90. So, but then we don't know what that angle is either. But what we do know is that this orange thing minus this green thing is 30. Sufficient. I mean, we literally only find what we want to find, which is the difference. So, any questions about that? We're going to look at testing cases in a second, but the main thing to notice here is that if you are focused on anything other than the correct goal, then you just kind of blew up the world. It's not going to work. So, okay, looks like we had a question being typed. So I will wait and see what that is. Gina's typing something. While Gina's typing, let's look at statement 2 just real quick. If you look at statement 2, let's say yellow for that. If you look at the angles PQR and PRQ, those are the angles that are here. Those are the other, sorry, I did that wrong. PQR is the top angle. That's the green one. So they're telling you that those two angles, why is it not 30? Sarah, this is a straight line together. This blue angle and this orange angle. Oh, are you saying, okay, I think you just have the wrong angle in mind. This is why we want orange angle minus green angle. So I think you're doing blue angle minus orange angle. So if you did that, then the way that you avoid doing that is just to write down more stuff on your work. So like just, if you ever wind up using the wrong quantities, just more labels, more directions, more reminders. Like if you write that like 4 different places on your paper, that's totally legit. So yeah, okay. Statement 2 is telling us that these two yellow angles are 150 together. What does that really mean? Yeah, it means the same thing as statement 1, because like if you, this is 180 degrees of triangle. So if these two angles are 150, then that means that this angle is 30. It's the same angle they gave us as 30 in statement 1. But this means the third angle in that triangle. Which we didn't color that angle in or anything, but these are two angles of the triangle. So the third angle is, which is angle QPR, is 180 minus 150, which is 30. So this is exactly the same as statement 1. So once you figure that out, you know this is also sufficient. So this is going to be D overall. Any questions about that? What's interesting is even if you have no idea how to solve this problem, if you notice that statement 2 is the same as statement 1, then there are only 2 possible answers. Let me know what those are. Yeah, it's either E or D. right? Like if you, let's make sure we know what I'm talking about. This doesn't happen very often, but it's the kind of thing, let's say that you have no idea how to do this problem at all. Like, or let's say I don't even tell you what the question is. Yeah, the question's not, just no question. Okay. Like as soon as you realize, like this means the same thing as, this means QPRs. As soon as you realize they're telling you the same thing, no matter what the question is, the answer is either D or E. Because it's if you think about what the data sufficiency answers mean, like the two statements are saying the same thing as each other. There are only two possible answers. D if they're sufficient, and then E if it's not. Because I mean, it can't be A or B, because A or B means that one statement is sufficient, the other one's not. I mean, obviously, if they're saying the same thing, that's not possible. The same information can't be sufficient one time, but not the other time. And then C means you have to combine them, but you can't. There's no meaningful way to combine two statements that are telling you the same thing. So yeah, it's not like witnesses telling you something to strengthen a testimony. I mean, this is just facts or not facts. So, in other words, if anybody guessed anything other than D or E on this problem, that was a logical mistake. So let's talk about testing cases. Testing cases. Let's talk about that. Same thing as algebraic. So if you don't like working with those algebraic expressions, then don't. I mean, do when you review the problem, but if you get lost with the algebra at all, then you should not keep doing it. Okay, this is 30 degrees. Remember, the goal of testing cases is to try different possibilities. And then if you can make two different answers happen, that's not sufficient. That's the goal of the whole testing cases method, no matter what. If you can, of course, keep getting the same answer over and over and over again, then that's sufficient. So that's the whole point of testing cases. So what you do is you just throw numbers in there and see what happens, right? So like, let's say that this is, I don't know, 17 degrees. Then 180 minus 30, I'm just going to use with a calculator, but make sure you can do this by hand. 180 minus 30 minus 17 is 133. And then this would be 180 minus 133. Which would be 47. So in this case, with the blue numbers, the answer is 47 minus 17 is 30. What we're trying to do is, if we can get an answer other than 30 at this point, it means not sufficient. Keep getting 30. That's sufficient. So try another angle. Say like 26. So this would be 180 minus 30 minus 26. That's 124. And then this would be 180 minus 124. It's 56. So the purple numbers, the answer is 56 minus 26. Still 30. I mean, you should be convinced at this point, because remember that these things are changing linearly, which means that either they will increment or they won't. If you're really stubborn about it, you can plug a third value in, but you're just going to keep getting 30 over and over and over and over again. So it'll be 30 degrees forever. So that's sufficient. Okay, and then statement 2 is sufficient for the same reason. So remember, there's a question in the chat about difficulty. Remember, don't concern yourself with difficulty levels. There's nothing to be gained from thinking about this. You just, every problem you see deserves your respect, basically. So, any questions about this problem? Now let's move on to another one. It's a good problem. I mean, the way they make these is pretty cool. I mean, like once you get used to this, they actually deserve a certain amount of admiration the way that they get this to work, like the way that they make these so that you literally only find the thing that you want and you don't find any of the other things. I mean, it's actually pretty cool how they do that. So. And I mean, when I talk about more generally about the mentality that you need for this, it's kind of one of those things where you should actually develop an appreciation for this kind of stuff. You know, where it's like, it can be frustrating until you get used to it, but once you get used to it, it's pretty cool. I mean, you can develop. It's like, the people who make the problems clearly have a skill, they have a talent for this kind of thing. So it doesn't matter which statement you start with, says the question in the chat box. Because either way, you have to use them individually. And if you have to combine them, you have to combine them. And if you don't, you don't. So it doesn't actually make any difference. So, yeah, and I mean, remember if you're trying to find that last comment, if you're trying to find the angles, just keep in mind that all of the work that you did after that was for nothing. Like as soon as this thought of I want to find these angles is in your head, you have already lost this game. Like anything you're doing after that is just kind of like running around because you already lost. It's like this problem. I mean, if you think I need to find X and I need to find Y, then all of the work you do is a waste of your time because you have already gotten this problem incorrect. Like in this problem, it's just you're going to find the combination, and that's what you're going to find. So there's a lot of these. I mean, once you get, especially if you're scoring above, then you're like mid-30s or so in the quant. I mean, like especially if the goal of the problem is pretty conspicuously specific. Like when you look at this problem, like they're specifically asking you for a difference. That's not an accident, guys. I mean, if you were going to find the angles, they would just be like, guys, what are the angles? So just think about it, right? Like if they ever ask you for anything this specific, you need to have this goal setting radar that like really turns on. Like whenever the question is this weirdly specific, goal setting is going to be everything. I mean, like literally if the question ever asks you anything other than like, what is this thing? Like if it asks you for a piece of something or a combination of something or a difference or a product or whatever, if it ever does that, then that means that you are not going to find the things that go into it, but you're just going to find the goal. So if it's like, what is the second digit of some integer after like of some number after a decimal point, that's the only digit you're going to find, guys. You're not going to find the rest of them. You get the point. So if it's like what is the greatest of these three values, you're just going to find, like if they're called X, Y, and Z, like what number is the greatest value of X, Y, or Z? It means you're probably just going to find that, but you won't know whether it's X or Y or Z, but you would still find what the greatest value is. So like anything super specific, anything that's not like what's X, what's this, what's that? Anything other than that, you know you're looking at a problem like this one. So okay, this one is also geometry. This actually tends to happen specifically often with geometry, because the material that they use in geometry is so basic. I mean, it's not only geometry, but it tends to happen particularly often in geometry problems. So remember where you get the multiple choice answers. There they are. Try that problem. Notice again, goal setting, guys. If you try to find the line, you're just going to be sort of screwed. Don't do it. Don't expect to find anything other than this point. Don't forget that there is, if you try algebra, it doesn't work, try testing cases. If you try testing cases, it doesn't work, then try algebra. So remember to give up on unproductive approaches quickly. One of these isn't working for you. There's one answer already submitted and it is incorrect. Okay, how are we doing this on? If you are still making genuine progress, that is actually progress. Just keep going. But if not, you should quit. It is interesting. Currently there are like 12, there's like 13 answers and only one of them is correct. So 1 out of 13. Negative hint. I mean, okay, goal setting, right? You give me a smiley face thingy if you understand what I'm saying here, that you are probably just going to find a 0. Smiley face, if that makes sense. Because a lot of you guys, in fact, 2/3 of people that picked an answer here have an answer that you should instantly doubt is correct because of this goal setting stuff. Like if you, in other words, if you find the entire equation of the line, you should suspect that you've gotten the problem wrong. It's kind of like me asking you for a digit of a number and you finding the entire number. I mean, if that ever happens, you should be like, oh, crap, I bet I got that wrong. So I'm looking at you. Everybody can pick choice C. I mean, this is a y-intercept and this is a slope. I mean, if you have these two items together, then that's like handing you the equation of the line. So not only is that way too much information, but it's also too easy. I mean, you should also suspect it on those grounds. You know, like you're going to have to do something that's harder than that. It's not going to be like mx plus b, well, here's m and here's b. So I mean, you should have a sense, by the way, of what the easiest problems on a test are like. I mean, if you go to the OG and you look at problems like 1 through 20 in the data sufficiency chapter, like just get a sense of how challenging those are. I mean, don't try to quantify it, but just try to get an intuitive sense of this is the easiest stuff that I will ever see at GMAT. Because even those things will be much harder than this if you think that they're just going to hand you a slope and hand you a y-intercept. I mean, like, nothing on this test is that easy. Nothing at all. So that means that you should just know right away. Even if you don't know why it's wrong, you should know that approach is wrong because nothing is that easy. So don't pick Steve. Don't do it. All right, let's talk about this problem. I mean, use smiley face if you see what I mean by this thing. So like, if you're just like slope, intercept, done. I got a line. Don't do it. Okay. Anyways, it should be pretty clear that statement 2 is not sufficient. I mean, if all you have is a slope, you don't really need to do work to show that. Like if all you have is a slope, then you can't locate any specific point. Because you can just move the line up and down, left and right there. I mean, like you can draw a line with slope 2 through any place on the x-axis, right? Like if you, there are actually 3 people who picked this as sufficient, so just for the benefit of those people. I mean, if you have a slope of 2, that means that roughly your line looks like about like that. It's up 2 for every 1. I mean, you can put that line through any point of the x-axis, guys. You can put it here, here, there, anything, right? Like here's A. These are 2 negative A's. These are 2 positive A's. This is definitely not sufficient. Give me a smiley if that makes sense. So at this point, you should actually be able to guess what the answer to the problem is. Like, if you get to the point of combining these, and you're like, oh, dude, slope, intercept, I'm done. You should do it, right? You should just say screw it and pick A. Because you should know that that's not how the problem works, and you should be 100% certain that that's not how the problem works. And so even if you don't see how A is sufficient, you should still have enough confidence to pick it. Because, I mean, in other words, you might not have any idea how this statement works, but you should still absolutely know that it's not going to be like, here's the slope, here's the intercept, I gave you a line. So, like, you should actually be able to get this problem right. If you realize the statement 2 is not sufficient, you should be able to get this problem correct, even if you have no clue how it actually works, which is pretty neat. But let's talk about it. I mean, this is the y-intercept. So they're saying that the y-intercept is 5 times the slope. So if we're going to test cases, let's test cases for statement 1. I mean, how are we going to do that? Like what is a case going to look like? We're going to test cases for this. Anybody tell me? Like how do you pick, like what does a case look like? Not physically look like not with your eyes, but like what constitutes picking a case for this statement? For this. Testing cases for that. that's algebra. We'll look at that in a sec. Sarah, what that discussion was once you have figured out that statement 2 is not sufficient. Oh, you're talking about this B. Sorry, I think I meant answer B to the problem. Okay. Yeah, and then once you have B, then you have a y-intercept and you have a slope, right? So you're going to pick a B. Like a case means pick B, which gives you the intercept and the slope. And then so you have a line. And then you need to find the answer to the problem. So find where the line hits the x-axis. And so that's not that awful, right? I mean, like the point is you just have to do this. Just organize it column by column. When you test cases, you can always put a step in a column and just make columns for each step. So pick B. That's just 3 free forms, pick varying y. And then, so that means that that's the y-intercept. The slope is 1/5 of that. So, and so then you have the equational line. And then plug in A0 and find A. This is what you should do whenever you test cases for a data sufficiency problem. You should just make columns for each significant step. So they tell you that the y-intercept is 5 times the slope, which means the slope is 1/5 of the y-intercept. So it's 5b is backwards. The b is 5 times this, so this is 1/5 of b. You know if that makes sense. Okay, so let's pick a b as like a multiple of 5. Just make our lives easy. Let's say it's 10. So the slope is 10 over 5. The equation of the line is y equals 2x plus 10. So just plug A0 into that. So 0 is 2a plus 10. That means that 2a is minus 10, so a is minus 5. Okay, if you get anything other than minus 5 out of any other case, then it's not sufficient. If you keep getting minus 5 for the rest of as long as you shall live, then it's sufficient. I mean, let's try out 500, and the slope is 100. I mean, ironically, Sarah, if you thought the slope was 5b, you would actually still get the problem right by doing these steps. I mean, you would get the wrong number for A, but you would actually keep getting the same wrong number over and over again, now that I think about it. So ironically, if you made that mistake, then it would not actually affect the problem. So, I mean, that's not a good thing review-wise, because usually if you do reverse relationships, it's going to screw stuff up. But it doesn't matter what this positive multiple is, as long as this is a, in fact, this can even be negative multiple. So as long as you have this number here, it's going to work out the same way. So, okay. This will give you y is 500x plus 500. So 0 is 100a plus 500. Look at that, still negative 5. I mean, maybe try a negative. That means y is minus 1x minus 5. So 0 is minus a minus 5. If you solve that, you're still going to get minus 5. I mean, if you really wanted like a fraction, you could do that too. It's not going to kill anybody, right? I mean, you should run the cases until you are convinced. I mean, if it takes you, part of that is your own degree of stubbornness, and part of it is how fast you can do the manipulations. But these don't have that many steps. So I mean, if you can run a few if you want, right? I mean, it just all depends. Like if you genuinely think that fractions might do something that other numbers don't do here, then you should try a fraction. I mean, but what you definitely don't want to do is try to make some prescriptive rule, like I need to try 4 cases. Like, don't do that, guys. Don't do it. I mean, because like trying 4 cases in a problem like this one would actually take a really long time, because you have to keep running those angles through all of those steps. And in a problem like this, if you honestly, dudes, ladies and gentlemen, if you get the same number out of 17 and out of 26, there's no freaking way that's a coincidence. I mean, that's how the problem works. But here, however it just, once you see patterns on this test, they're not fake. That's the most important thing I can tell you. Like, there will not be a problem where you have to, there will never be a problem where you have to come up with some crazy out-of-the-way value that you would never think of to break a pattern. It's not going to happen. So, just as long as you realize that, you should be fine. Like, I wouldn't test the fraction here, but if you're convinced that a fraction might do something, then try it. Right? This would be 1/5 x plus 1. So, and if you solve 0 as 1/5 a plus 1, you'll still get back to 5. So, yeah, look at that. That's sufficient. It's going to be a minus 5 forever. So that's a. That's testing cases approach. Don't forget, when you review these things, you need to review mostly the methods that you do not use much. So if you are the type of person who will just do algebra all day, then this type of approach should be like 90% of your review of these problems, because that's the only way you're going to get better at anything. If you, it's kind of like you're an athlete with a lot of strength and a lot of speed, but you don't have any flexibility. I mean, in that case, you should do a lot of stretching. This is the same sort of thing. Also, make sure that you are humble enough about the effectiveness of your methods. I mean, like if you are someone who uses algebra all the time, and you are honestly really good at algebra, and you tried algebra on this problem, and you still got this problem wrong, think about what that means, guys. It doesn't mean that you should keep studying algebra. That's not what it means. It means that there are other things that you should learn and do them. So, like this. Yeah, we're going to do the algebra here in a sec, but I mean, the biggest thing that you can do on this test to do better at it is to become well-rounded with your approaches. I mean, because you're never going to have a level of, I mean, the problems are made so that no single method will work on all of them. So, like, there are a lot of problems where you have to test cases. There's no other way to do it. So, just make sure that make sure you're not invested in, make sure all of your investments are not in one stock, so to speak. Let's talk about algebra for the statement. So, okay, the y-intercept is 5 times the slope. So, that means that you can say that the slope is m, and then the y-intercept is just 5m. So that means the equation of the line, you can write that as y is, remember it's slope x plus y-intercept. So that's mx plus 5m. you could also write it as b over 5 times x plus b. That would work too. Either way. Make sure that you review that as well. You could also do that. If you want to keep the original b, you also write y equals b over 5x plus b. It's not going to make any difference. So the smiley face, if that makes sense. The point is that you just need to have this relationship. You need to have this needs to be 5 times that sort of thing. So what are we doing with this equation? What's the goal of the problem? It's just going to tell it. Yeah, you plug in A0 and you solve for A. So yeah, you plug in 0 for y and A for x. So if my name was Vishnu and I was on the internet, I would just talk to everybody about what is my avatar on this social media. Ha ha ha. Okay. You solve for A. That's what you do. So 0 is n times A plus 5n. We factor out n. So n is not 0 because they told us that it's not horizontal. I mean, if this product is 0, one of these has to be 0. So either that or that. But this is not possible because we don't, they specifically told us this is not true. So non-horizontal means, because horizontal lines have a slope of 0. So that means that A plus 5 is 0, and if we know that, then we know that A is negative 5. So there we go. Efficient. Any questions about this? I mean, again, the most important thing here is that if you know that, once you realize, I mean, statement 2 being not sufficient should be pretty fast and painless. And once you realize that, if you get to the point of trying to combine these, you should just take a step back and be like, nope, that's not how it's going to work. And once you realize that, you should be able to pick A with lots of confidence, even if you have no clue how A works. I mean, you can do that. You can have that much faith in how these data sufficiency problems do and don't work. And I mean, as much as people don't like adaptive tests, this is also one of the things you should really like about taking an adaptive test, is that you should know that they're not ever going to give you anything as easy as like, dude, here's M and here's B, now go. So that's all of that is helpful stuff. Let's look at one more. Let's do one more geometry problem, actually. There's a couple of problems in my slides here that are not geometry, but well, I guess we'll get to those. We do another one next week, by the way. The next Thursday with me is the 15th, and I think we're going to do more of the same topic. So try this problem. Don't forget where the multiple choice answers are found. Go for it. All right, let's see what we're doing on this. I mean, this problem is not that long, so the other thing about these things, I mean, make sure you're not using 2 minutes as some sort of universal standard. I mean, like this problem here is that we did before, like you're not going to finish this problem in 2 minutes. So don't try. Like, you know, you're probably 30, 45 seconds into this problem by the time you just figure out what this even means. Like that this is slow and y intercept is 5 times slow. And then if you're going to test the cases, you got to do that stuff with like picking stuff and making equations and then plugging into them. And if you're going to do algebra, this is still, you got to get oriented to the algebra. You got to figure out these substitutions. Then you got to plug this in. I mean, you're not going to finish this in 2 minutes. So if you have this weird idea that you have to solve every problem in 2 minutes, problems like this you will just never get right. I mean, but just remember what 2 minutes is. I mean, 2 minutes is an average, guys. 2 minutes is the average time, which means that you're going to be over 2 minutes as often as you're going to be under it. So like this problem should not take you anywhere close to 2 minutes. I mean, this is just look at it. There's not really a lot of stuff happening there. So don't. I mean, okay. Now let's talk about goal setting. What do you expect to find in this problem? Like, this is a super weirdly specific question. That's what you expect to find. You think you're going to find a specific point? I don't know how you do that, though, because the facts that are given are about the line, not the... And I mean, if you're picking points in the third quadrant, that's the other problem, is that, because remember what the goal is, right? This is a yes-no question. Like, to get not sufficient, you have to make this happen, and then you have to turn around and make it not happen. So, like, not sufficient means you can make the line hit the third quadrant, and then you can turn around and make the line not hit the third quadrant. So if the first step of your process is start in the third quadrant, then that's not going to do it. That's not going to work. So you would think everything was sufficient all the time. Do you think you're going to find the equation of the line? Or do you think you're actually going to find where the line is? Do you think it's going to happen, guys? Do you think you're going to find the line? I mean, determine the position of, when you say the position of the line, that makes me think, that sounds to me like exactly where the line is. Which, nope. This is the goal. You should expect to not find a single line in a single position. In other words, you should expect Like if a statement is sufficient, you should expect to find whether it hits the third quadrant. But that's it. Like you should not expect to find a single line. If you think you're going to find a single line, then you have lost this game already. I mean, it's kind of like the last problem. I mean, if you think you're going to find, in other words, if you think you're going to find the M and the B, in other words, if you think I need to find the M and the B in y equals mx plus b, you lost the game already. Yeah, too bad. You lost. Try again next time. And that's how these problems work, guys. It's all about goals. I mean, trying to find the line is the wrong goal. Don't do it. Okay, so also the other thing about this problem is that you can't do it. There's no algebra in this problem. You can't do it. Like this is because quadrants are not an algebra thing. And like there's no way to algebraically show that something is in a quadrant. Because quadrants are positive, negative. There's no substitution for that. You can't. It's not like an A0 where you can plug A and plug 0 find a point. I mean, there's no algebraic thing for this. So what you're going to have to do, since there's no algebra, because like everything we did for this problem, for example, was algebra. Like even when we tested cases, we still plugged cases into an equation. But here you can't use equations to do this because equations can't show you that things are in quadrants. So you can expect to not use equations at all. And yeah, so we're just going to have to consider it visually. This problem is a nice smack in the face to people who think they have to do algebra or everything. No, don't do it. Okay. Statement 1. I mean, also make sure that you know what not sufficient and sufficient mean. I mean, this is a yes/no question, right? So like not sufficient means that you can get the yes and get the no to that. So like not sufficient would mean you can hit the third quadrant and your line can miss the third quadrant. That's what not sufficient would mean here. If only one of these can happen, then that's like if one of these is impossible, then you're just stuck with the other one. That's what sufficient means. Okay, so statement 1, like what does the slope of 1 out of 6 look like visually? And you know you have to do this visually because again, it's about quadrants. Quadrants are visual. So I mean, quadrants are also positive, negative cases, but you can't plug positive and negative cases into a slope. So that means that visual is the only way left. So what does that look like in terms of like upper left, lower left, upper? Like as you go from left to right, what does this do? It goes, yeah, it's not very close to horizontal, but like as you go from left to right, what does it do? Let's go up, let's go down. Yeah, it slopes up from left to right. Like this, like very gently enough. I mean, it goes over 6 units for every one that it goes out. And also it's a line, it's not a segment, so it doesn't ever stop. But this ratio is supposed to be bad vertical line. The ratio of these steps let's try it again. The ratio of that horizontal step to that vertical step is 6 to 1. For every 6 it goes over, it goes up 1. So, but the line doesn't ever stop though. So I mean, you can hit the third quadrant, but you can't miss the third quadrant. Like no matter how far up your line is, I mean, if you just keep following it this way, like if your line is 1 billion units above the x-axis, all you have to do is go 6 billion units over to the left, and it will eventually get into quadrant 3. So for statement 1, this is sufficient. You can't miss the third quadrant. It's impossible to miss it. So that's sufficient. I mean, notice again, goal setting wise, you find exactly what you want to find, which is like the judgment of whether it could hit the third quadrant. But you don't find anything else. Yeah, so if they told you negative, I mean, they wouldn't make a negative slope with this question because then it would be like, oh, here's M, here's B. Like, they wouldn't make the problem do that because then goal setting would not be a factor. But what you're writing is true, but they would not make the problem do that because then the goal setters would not be rewarded over the la la la, I'm just going to find everything people. So, okay, that's statement 1. We got to run through this statement 2 pretty fast because technically over time already, but let's do that really quickly. I mean, statement 2 just tells you where it hits the x-axis. It's a positive value. 7, 0, that's over here somewhere. I mean, if you know what the goal is, this statement should be short work. I mean, you can make a line that misses the third quadrant. And then you can make a line that hits it. That's no sweat. So this is not sufficient. You can make both of those things happen. So this is A alligator overall. And if you thought I gotta find the line, guys, then you are a goner right off the bat because you're gonna get C. But the only way that you could correct that would be like if you did think that and you got to combining these, then you should be like, oh, there's a point and there's a slope. If you have a point and a slope, you have a single line. I know that would just be way too easy. Like they're not gonna make it that easy. Let alone ignoring this whole. Because like the even bigger deal about taking C here is that C doesn't think about quadrants. Like C is just like, dude, I have a line, and so I'm happy. You should definitely know that that's wrong. I mean, if there's one thing that is absolutely certain here, the questions are not stupid, right? Like if they give you this question, you're actually going to have to use A to get the problem right. If they give you this question, you're going to have to actually subtract those angles to get the problem right. If you give you this problem, you're going to have to actually use the expression 2x plus 2y. You're not going to ignore that and just think about x and y. Like same thing here. In this problem, you will definitely have to think about quadrants. So if your thought process doesn't depend on quadrants, then your answer is wrong. Right? That should be straightforward enough. But if you pick C, then the whole entire thought process has nothing to do with quadrants. Like it would just be, oh, I have a line. Therefore, I can answer any question about a line. Don't do it. Okay. Let's kill it. Around 5 minutes over already, so thank you. The next one of these programs is actually next week. So it's the same time, it's a week from today. And then that's the last one of the calendar year. So I'll see you guys in a week. I think you still have to sign up every time. I mean, I know it's annoying to do that, but I don't think there's any way around it. So, okay, I got to run. I'm on schedule. Thanks, guys. Cameron, if you're here, then you just do the same thing you did for this one. So it's whatever the procedure is, same every time. So, okay. Good afternoon, good evening, good night. But talk to you next.